Test 1 2. Check 1 2. Test 1 2. Test 1 2. Check check check. Check check check. Test 1 2. Test 1 2. Test 1 2. Test 1 2. Check 1 2. Test test. Test 1 2. Check check.
No, we're a little different than we do work with them on occasion though.
Test 1 2. Test 1 2.
We're a little edgier than them. But we do work together on a lot.
Test 1 2. What?
No, I have sound coming in.
You have what?
I have sound coming in.
You shouldn't.
I know.
Is that on? Good evening, everyone. Good evening. Welcome to Science on Tap. It's a very special night for us. This is our 11th anniversary of Science on Tap. Thank you all for coming all these years. And thanks so much to Mary Taylor for bringing us cookies, celebration cookies. So thanks very much. Oh, she did not make them, but she did the hard work. She brought them. So thanks for coming. My name is Susan Knight. Science on Tap is an example of the Wisconsin idea, an idea conceived in 1905 that the boundaries of the university are the boundaries of the state. Our partners in Science on Tap are University of Wisconsin Trout Lake Station, University of Wisconsin Kemp Natural Resources Station, and the Lakeland chapter of the Wisconsin Alumni Association, Minocqua Public Library, WXPR, and of course our wonderful hosts here, the Rocky Reef Brewing Company. Almost forgot. And we also thank the Brittingham Fund for a grant to the University of Wisconsin-Madison. Our next Science on Tap event will be on March 7th. We will have Brian Berenger to talk about cannabis and a new program going on at UW Stevens Point. So don't miss it. Okay, but tonight we have Peter Levi of Northland College in Ashland, Wisconsin. Peter is a freshwater ecosystem ecologist at the Burke Center for Freshwater Innovation at Northland College. He will discuss the ecological, social, and economic dynamics of water in our corner of North America's largest watershed, the mighty Mississippi. Peter Levi is a freshwater ecosystem ecologist passionate about teaching, field and laboratory research, and science communication and outreach. He grew up in south central Wisconsin. In his youth, searched for crayfish to sell to anglers. I think he's responsible for all the rusty crayfish in the entire state. in his hometown from the Rock River. Now, as a scientist and educator, he explores how changes to lakes, streams, and reservoirs have cascading impacts on other processes within these ecosystems. And he tries to tease out whether these changes have human or natural causes. He's worked in aquatic systems all over the world, from the Great Lakes to Denmark to Alaska to Africa. He earned his undergraduate degree from Lawrence University and his graduate degree at the University of Notre Dame. And Peter Levi, along with 2 others, is teaching a Fee University. Do you guys know Fee University up in Iron County? Yeah. A great program. They have all kinds of classes up there. Fee as in F-E, Iron County University. I'm pretty sure you guys all got that. But anyway, they've got some great classes up there, and he is teaching one called From Freshwater Shores to Shining Saltwater Seas, an investigation of environmental crises along the Mississippi River and beyond. It is in Hurley, so it's not as easily attended perhaps as some of their classes, but still could be worthwhile. Now, per tradition, here is your trivia story about Peter Levi. Peter has worked in aquatic systems all over the world, including the Laurentian Great Lakes in Denmark and salmon-filled streams in Alaska. Where else has he worked where the natives were not always friendly? The wetlands of Ghana, filled with crocodiles, the Orinoco River in Venezuela, filled with piranhas, or the Everglades, filled with pythons. So, crocodiles, piranhas, or pythons? Crocodiles. Here's Peter Levi.
Well, thank you, Susan. That was quite an introduction. I should ask you to write my bios all the time. Thank you all for coming out tonight. As Susan said, my name is Peter Levi. I'm from South Central Wisconsin and very happy to be back. I just moved back here with my family 2 years ago and am the Associate Director of Inland Lakes at the Burke Center at Northland College. I don't have slides, and there's a projector, guys. A scientist without slides is just adrift. So I'll do my best. And I did bring books. I heard that there was a raptor here a month ago and cannabis next month. So I was going to talk about water, which is an important topic. So I thought that I'd share just some ideas that got me excited about water, got me excited about studying freshwater systems, then talk a little bit about what I've done in the Mississippi River watershed, and then talk about what I'm doing here, sort of looking forward and thinking about how unique and special this place that many of you live if you are a resident here or at least you're visiting. So that's kind of what I wanted to do in 20 minutes. So first I thought I'd talk a little bit about water. I'm a biogeochemist, which is another similar to freshwater ecosystem ecologist. And what that means is I like to think about the chemistry of the environment and then how biological processes and geological processes influence that chemistry. So thinking a little bit about chemistry, H2O, oxygen has that really unique relationship with 2 hydrogen atoms forming a 104.5 degree angle. And you surely all have thought about H2O a lot in your lifetime, but it's pretty amazing in that when you start to think about the chemistry of it, it's a really light molecule. Oxygen plus 2 hydrogens is about 18 grams is the atomic weight. And if you think about all the other molecules that have a similarly really light weight, you can think of methane, CH4 is about 16. Dinitrogen gas is about 28. These are all really light, but if you think about those, how do we mostly experience those molecules? Gas, exactly. Water is super unique in that it's a really light molecule, yet we experience all 3 phases of it. Sadly, not too much of its solid phase at this time as a skier myself. So it's really amazing that this super light molecule can be a liquid, solid, or gas within a pretty narrow band of temperatures. And if we were to compare that, you think of something like nitrogen. I mentioned dinitrogen, which is what we're swimming in, right? 3 out of every 4 breaths you take is dinitrogen gas. If you were to split it up, it's about 72% of our atmosphere. And you probably have all heard of liquid nitrogen, right? Liquid nitrogen is really cold, so it has a really, really low boiling point. Negative 100 some degrees Celsius. Similar with carbon dioxide, it's what we know mostly as a gas. There is a solid form of that. There is actually no liquid form of carbon dioxide, and the solid form is dry ice, something else that you may have come across in your lifetime too, but that's really, really cold. It sublimates right from the solid to a gaseous phase. So I get really excited about chemistry, but in an environmental context. I have friends who are great chemists and they spend their days in labs. I do that sometimes, but I like to get outside. And so I brought some books with me if anybody wants to talk more. Biogeochemistry, it's a fascinating topic. And I'd be happy to talk about it. Some call it a textbook. I call it, bedside reading. But it's a really good book, and just thinking about the cycles of these elements in our natural world and in us, right? The element I've studied the most recently is nitrogen, so I'll talk a little bit about that today. So that's kind of how I view the world as a biogeochemist, thinking about things like water and how unique that is. And I also think about how unique this place that we call home is, too. As a native Wisconsinite, I grew up in Watertown. And there's a lot of rivers and lakes down there, but of course, so many more up here. And when I was an undergraduate at Lawrence, I came here, stayed at Camp Manitowish, where my spouse worked for many years as well, so we have a lot of connections to this area. And we studied with our advisor at Crystal Lake, at Trout Lake, so did some work on these lakes as an undergraduate. And then I did some other traveling during my post-grad years, and then ended up at a lab in Ohio. And in Ohio, they study reservoirs a lot, and I was a bit of a snob because reservoirs are not lakes, even though so many are called lakes. So it really changed my perspective, though, and to think about how unique we are. In Ohio, I looked this up today to remind myself of the numbers, there are 12 natural lakes, 100 acres or larger. Crystal Lake, if you know Crystal Lake, just up the road, is 93 acres. So Ohio only has 12 lakes that size or larger, just to put it in perspective, right? They do have 112 reservoirs that are 100 acres or larger. So there's a lot of dammed rivers, especially south of here. And so that led me to think about one of the things I wanted to share with you about how unique this place is that we have so many lakes, so many natural lakes, whereas the rest of the US and many parts of the world don't. And the reason for that, as you may imagine, is again, water and its solid form. 10,000, 12,000 years ago, the glaciations that occurred over that 100,000 years previously led to the landscape that we have today. Most of those glaciers stopped right around current borders of Wisconsin with Illinois, Minnesota with Iowa, Michigan with Ohio and Indiana. And so from those borders south, it's primarily rivers and streams. Very few natural lakes. So this is a really unique place that we live. And so thinking about what I wanted to do with my life, as I was working in Ohio studying reservoirs, I thought, well, I really want to travel. And so Susan mentioned some of the places I was able to travel, very fortunate for that. But I realized that if I wanted to travel and do science, I should study streams and rivers. Because anywhere you are, you're in a watershed, right? Anytime you're on land, if it rains on you, water's going to run off to the nearest stream or river. That'll flow downstream to either a lake or the ocean. And so I knew that if I wanted to see the world and do science, I should study streams and rivers. Thinking that I could never get a job in Wisconsin because there are so many really, really good limnologists here, couple in the crowd tonight. And so I started studying streams and rivers, which are really fantastic systems, but also really hard to study because water is always moving in them. And so I was looking for programs related to streams, and I came across the opportunity to work with someone at the University of Notre Dame. She's known as Dr. Nitrogen. So naturally, I started thinking a lot about nitrogen. And there's another great book. I feel like there could be a great book written about every element. And so this is the story of nitrogen. Dan Egan, if you know Dan Egan, just came out with a book called The Devil's Element, and he talks a lot about phosphorus. So those are two of my favorite elements. And so I wanted to talk a little bit about that in the context of the Mississippi River watershed. So here we are in northern Wisconsin, a super beautiful landscape, and the water that is flowing past us here is flowing eventually down into the Mississippi and into the Gulf of Mexico. And so there's some really important social, economic aspects to that. And as an ecologist, that's what I studied most, but I've been around and can touch on some of the socioeconomic things as well. And so nitrogen's really unique. It can accept or give a lot of electrons, so it can take 8 different valence states. So it's a trickier molecule and atom to study than others, but that makes it also pretty fascinating. So from this part of the Mississippi River watershed, we have pretty pristine landscape. As you move south, it takes about 90 days, 3 months, about 90 days for a hypothetical water molecule to go from Lake Itasca in Minnesota all the way down to the Gulf of Mexico. So pretty short time. I imagine it would take considerably longer from this part of the Mississippi River watershed, given all the lakes that it would stop in on the way. I have so much that I want to say, so I'm just trying to, that's why I keep thinking about, oh no, I forgot to say that. I have a joke. Yeah, I only have 20 minutes. So much science, so little time. My joke, because I feel like I'm a comedian up here with the light on me, we're always in a watershed, right? And that's why I was pausing earlier. I was like, dang it, I forgot that, but I'll go back. So I met a colleague at Drake. I was a professor at Drake University for 7 years in Des Moines, Iowa. And I met a professor, and I said, oh, I study water, and I think about watersheds a lot. And he said, oh, I hiked into a watershed this summer. I said, oh, you were probably in one before you, and he said, oh, I was in the mountains, and there was a sign on the trail that said you are now entering the blah, blah, blah watershed. So it just demonstrated to me that, some concepts that we take for granted, like, hey, we're always in a watershed no matter where you are when you're on land, isn't necessarily a concept that everybody's familiar with. So it's an important one to think about. So Mississippi River watershed, it's really old, which is really fantastic too. There is some of the highest diversity of mussels in the Mississippi River than anywhere else in the world. And that's because it's 70 million years old. The Mississippi River has been flowing for a long, long time. In fact, it's been flowing since dinosaurs were on the planet, right? And that's a lot more than we can say about the Great Lakes. As wonderful as they are and as much attention as they get in this area, they are, only 10,000 years old, at least the water in them now. And so that has huge ramifications for not only the physical aspects of the lakes, but also the biological ones, right? Evolution hasn't been able to work on the organisms there for quite as long. So there's much less diversity there than in the Mississippi River, which again has been flowing for much, much longer. And so the current state of the Mississippi is in relatively rough shape. You may have heard recently that there was a major drought, so water levels are lower. There's also a salt wedge due to that drought that's creeping up towards New Orleans, threatening their water supply. And so these are some of the aspects that I like to try to inform with some science. And so the course that Susan mentioned that we're doing in Hurley right now is based on this book, Breakpoint, which is another really good one, about reckoning with America's environmental crises. And so one of those crises that they mention is just the excessive amount of nitrogen that we've harvested from the atmosphere. So I told you I really like to think about chemistry. And nitrogen's really fascinating, right? As I've already mentioned, dinitrogen gas is all around us, 3 out of every 4 breaths you take. But it's really hard to get at that nitrogen. Dinitrogen gas is formed with a triple bond, so those 2 nitrogen atoms are really strongly attached. We figured out how to break that bond right around the 1920s because of World War I. So war is a great innovator, for good or for bad. People want to think of how to make more destructive things. And so the Haber-Bosch process, Bosch of the same Bosch as the spark plugs, figured out how to break that triple bond of nitrogen and then be able to access active and reactive nitrogen. So the TNT, the N in TNT is nitrogen. That, of course, led to a lot of deaths and some terrible things. And then after World War II, several decades later, suddenly we had this technology, but there was at least some peace for some short period. And so we realized that a lot of our fields and our agricultural areas were deficient in nitrogen, which is what led to the Green Revolution and the huge population boom of the 50s and 60s, starting to fertilize the landscape with nitrogen. Which kind of brings me back to the Mississippi River and thinking about my former home in Iowa. I always felt a transient there, by the way. We had a little koozie. Ray Gun is a great store in Des Moines that is really funny. And we had a koozie that showed the state outline of Iowa, and it said captive in it. So, so we've been freed. So Iowa is an agricultural state, and it produces the most corn in the U.S. It has the most pigs in the U.S. And so it is this epicenter of industrial agriculture. And whenever I talk about agriculture, it's very important to realize that we all benefit from it, right? It's a very important part of our economy, and there's many people whose livelihoods depend on it, and we depend on eating, of course. So agriculture is important for our country. However, the way agriculture is practiced, especially in states like Iowa, could be improved. And so there's a lot of nitrogen applied to the landscape. When nitrogen is applied, it's applied as anhydrous ammonium primarily, or manure. Both of those forms are really easy for plants or bacteria or organisms to take up. So they're applied in that form. However, microbes can convert that ammonium to nitrate. And nitrate, what we in the biogeochemical world refer to, is a leaky molecule in the very scientific terms. So it usually doesn't stay where you put it. And we see that a lot in the Mississippi River Basin. If I had slides, I would show you a map of how much nitrogen is pouring into the Mississippi River from the agricultural states, Iowa, southern Minnesota, Illinois, Indiana, Ohio. Massive amounts of nitrogen. And that doesn't have as much impact on the ecology of the Midwest, but it has major impacts on the Gulf of Mexico when it reaches the Gulf. And what it does is it causes a major algal bloom annually. There's some amazing scientists at Louisiana State University and LUMCON, a research center on the coast, who have been studying this since the 80s. And the 2 factors that predict how big this dead zone will be is the amount of fertilizer applied in the agricultural Midwest and the amount of springtime rain in the agricultural Midwest of that year. And they can do a pretty good job at predicting how big this dead zone is going to be. The dead zone occurs because all those algae that bloom when they get fertilized by the nitrogen, same thing as to why we put fertilizer on the landscape, they bloom, they die, and then as they sink, they are decomposed by microbes. And decomposition is an anaerobic process. It uses oxygen. So it sucks oxygen out of the water, creates an area of no oxygen. The porpoises in the Gulf are fine because they're breathing the air, of course, as they surface. Fish can swim, but think of the shrimp, right? Recently, a dead zone was as large as New Jersey, and Christine Todd Whitman, former governor of New Jersey, and then later the EPA administrator in the Bush administration, asked if they could not reference New Jersey when they talk about the size of the dead zone. But you can imagine a shrimp. You can imagine a shrimp trying to go down the New Jersey Turnpike, right? Like it's not going to get out of Jersey before it has to breathe. And so that's a major issue for a lot of the industry and the quality of life in people who live along the Gulf, right? So that is from nitrogen in the agricultural Midwest. So watersheds connect us all, and that's a really important concept to think about in all of ecology is the interconnectedness of humans with the landscape, but also all the processes within the landscape. So I was studying how quickly nitrate can be removed because there are microbes who will use nitrate through a process of denitrification. They take that nitrate, use it as an energy source, and then they emit dinitrogen gas. Again, that would be great because we're swimming in that. And so I measured that in one of the rivers that was really high in nitrate in Iowa, and I found that the distance that river would need to flow was several times to the moon and back in order to remove the amount of nitrate that was in it. So clearly, that's the epicenter of the problem. Other scientists have since measured Iowa is about 5% of the land area, the Mississippi River watershed. It spans parts or all of 31 states, 2 Canadian provinces. So Iowa is just a small, less than a 20th. They contribute 29% of the nitrogen. So less than 5% of the land contributes almost a third of the nitrogen. So we're trying to think of how to solve this. There's those of us ecologists or stream folks in the stream, and we're being told, how do we prevent this? And that's really frustrating because we can't. There are conservation things that are being put in place. There's saturated buffers, there's bioreactors, there's a lot of different things. But really the elephant in the room is how much nitrogen is going on the landscape in the first place. And that isn't being discussed as much, or at least that's a topic that you can't bring up. So that was really frustrating. It led to a lawsuit that I was able to be an expert witness for. The water utility in Des Moines sued 3 upstream counties. The case was thrown out because the Iowa Supreme Court ruled that stare decisis, I learned a little bit of Latin, stare decisis means that the precedent reigns, and the precedent was that nobody had ever been sued before for high nitrogen levels. So that seemed frustrating. They also ruled least cost avoidance. So this is some of the socioeconomic things that I've been able to be involved with as a scientist. Least cost avoidance means that it was cheaper for Des Moines Waterworks in the city of Des Moines to treat the high nitrogen water, which at times could be $10,000 a day to run the denitrification facility. It was cheaper for them to do that than for agriculture to change, which makes sense. It would be really, really expensive, much more than $10,000 a day for agriculture to change. But it's also something frustrating because then that cost is put on the ratepayers in the city of Des Moines. It's been interesting thinking about nitrogen, especially in the agricultural Midwest. It's really leaky. It can cause different forms of cancer, esophageal cancer, pancreas problems. Iowa is one of the only states in the country where cancer rates are currently going up. Yet another reason I was glad we were able to move. And so there's some clear linkages, of course, between how we live on the landscape and how we then live. So I think that's something really important too, thinking about the water that connects us. So finally, I think I have to wrap up already. I was just getting started, Susan. I usually teach semester-long courses. This is really hard.
Okay, great.
Am I done? Oh, she's stopping me.
Are you done?
Well, I was going to mention one more thing. That's what I've done. I told you I'm so happy to be back here. I should tell you what I'm doing here, right? If I could. So I'm part of the Burke Center. Our director is Peter Annan. He's written a couple books. Great Lakes Water Wars talks all about the Great Lakes Compact and the protections that were put in place to keep Great Lakes water in the watershed. I could talk all about Waukesha if you want. I grew up in Jefferson County, right next to Waukesha County, so happy to talk about that diversion. First diversion of Great Lakes water ever outside of the basin. That's a whole another science on tap. April, do you have somebody for April yet? And then he just came out with a book called Purified. This came out in November, and the byline is, if you can't read it in the way back, how recycled sewage is transforming our water. So water, of course, cycles, and we've been doing this for years, right? If you pull water from a river, if you live in a city that pulls water from a river, you're pulling somebody else's waste into your water treatment facility. But now, places in California, Texas, elsewhere are doing this, sending from the water treatment facility, a wastewater treatment facility, right to the water treatment facility. And so this is directly going from one facility to the next. It's actually cleaner and easier and cheaper than pulling water from the environment. So that's a fascinating book. And what I'd end on, I'm doing some work now on Lake Namakagon. We have some buoys out there. I'm really excited that I get to focus on the inland lakes. My colleague focuses on the Great Lakes. But what Peter mentions in the end of Purified is that there is no compact for the Mississippi River. There are no protections on the Mississippi River water. And Arizona has a few people in their state legislature that have already had the ideas of diverting water from the Mississippi across the mountains into Arizona. And so it kind of, we are in the Mississippi River watershed. So far they've said, in Arizona, they've said, well, you have such big floods, we would only take the floodwaters. And so the Mississippi is experiencing a drought right now, right? So it's a vexing socioeconomic problem as well as an ecological one. And so that's like, I was just getting started.
Great. Well, thanks a lot. Okay, we're going to get some questions now, and Amber will walk around with the microphone. Please remember, put it real close to your mouth so that everybody can hear, and remember that we're taping this, so we want to be able to hear all the questions. So raise your hand if you have any questions, and Amber will come around.
I grew up in central Wisconsin, and we had a situation years ago during drought years where we noticed that low-flowing rivers would actually accumulate in dead pools carbon monoxide. Have you ever experienced that in areas on the Mississippi?
So the question was about dead pools emitting carbon monoxide, did you say?
They were holding it because it wouldn't flush. They would hold because it wouldn't flush out. It was actually at a Kiefer marine outboard testing facility. So the exhaust was putting it in, but you didn't have the flow and the flush rates to move it out.
Yeah, so that sounds, it's probably unique to that situation, but when you have those dead pools forming, you can get a lot of, again, those could all form little dead zones. All the oxygen would likely be used up, so whatever organisms are in there would not fare too well. Yeah.
You had mentioned mussels, so can you talk about freshwater mussels as a bioindicator?
As a biogeochemist?
No, as a bioindicator for, yes.
As a bioindicator. So yeah, mussels are really fascinating. They are, so bioindicators are organisms that are kind of sentinels, right? So we can use certain organisms to indicate the quality of the habitat, the quality of the ecosystem. And mussels are really unique because they don't move, right? They're sessile. They do move as a larval stage, so they can move downstream or upstream. They're fascinating. If you've never looked at how mussels reproduce, it's actually really worth it. They stick out what's called a glochidia that looks like a fish. So they bait other fish into eating their eggs or grabbing onto their eggs, and then all the glochidia disperse and they attach to the gills of the fish that was about to eat this fake fish, right? Amazing. Question was bioindicators. So they are really good at that. Yeah. And they do a lot of biogeochemistry. They release a lot of phosphorus. So they are really good bioindicators because they sit still and they take what they're given, right, from the water. So if your water isn't of high quality, the mussels will perish. If there's a lot of toxins, they accumulate those toxins. And so that's why there is still, I think the mussels in the Mississippi are sort of a really good example that the Mississippi isn't that trashed. that they are still there. It's some of the highest mussel diversity in the world. So it's a really unique ecosystem. But we also have to be really careful and proactive in protecting them because all that sediment that could be flushing down from the way that we've modified the landscape could cover those mussel beds. So yeah, they're still there and it's really promising and they have really cool larval stages. Yeah. Yeah.
We're in the country, as you, part of the, that you brought up of coming back to lake country. This lake country is full of dams, and we have a major power company that's been running the river for over 100 years to all these small lakes. So we have accumulation of nutrients behind a typical dam, and of course these larvae that you're talking about, walleyes, they can't move. Okay, does it create a good fishery? But my question for you, being a geochemist, what solutions do you have to tie up these nutrients to make the system work again?
So a lot of the nutrients that cause algal blooms here in lakes are driven by phosphorus. And a lot of phosphorus can be bound to sediments. So I mentioned nitrate can be really leaky. On the flip side, phosphorus can be really sticky. It stays often where it's put or where it might run off to. And so as far as I know, having just been up here for the last 2 years, we have such low nutrients relative to where I've worked before, right? So it's not really an issue. Yeah. In relative terms, yeah, and that's one area I've just been looking at some data primarily from Schwamigan Bay, and Schwamigan Bay has really low nutrients, and we're not seeing the algal blooms. But I would love to talk more about the lakes around this area. I've been working primarily on the Pinocchi Lakes around Mellon, Wisconsin, and then also Lake Namakagon, and those are very low nutrient lakes. But there's less development on the Pinocchis especially. Yeah.
I've got an online question here. How much of an issue is nitrogen in the Namakagon and Fish Creek watersheds in the Ashland and Bayfield County area?
Yeah, my perspective is really skewed from living in Iowa for 7 years. So I'd say it's not that bad. Again, nitrogen doesn't cause a lot of the algal blooms in fresh waters that we see in marine waters. And so the concentrations are relatively low. The bigger issue in Fish Creek and, primarily Fish Creek is erosion, bluff erosion, and that delivers a lot of phosphorus to Schwamigan Bay. Again, bound up to sediments though. And the Namakagon, as far as I know, I haven't been on it for science yet, is relatively low nutrient as well. So most of those nutrients are tied up in the lake upstream of the river, of Namakagon, that is.
Hello. Wisconsin has a lot of land trust organizations that sets aside areas that don't get developed. I know it's not your wheelhouse, but what is happening in Iowa? Do they have any type of move toward setting aside lands that would normally be agricultural, and then they can try to reclaim it so that you don't have this infiltration into the Mississippi River?
Yeah, great question. Iowa has the least amount of public land of any state in our union. So another reason to leave. And yeah, so there's just, it's all tied up, a lot of private landowners, and what's happening is a lot of consolidation now. So a lot of larger and larger farms. There's a lot of tenant farmers in Iowa as well. So again, we need agriculture, and farmers are land stewards. But tenant farmers are less land stewards than maybe the people who own a farm. So, they're primarily focused on hitting their yields because their livelihood depends on it. So there's some movement towards, this is covered a lot in this book, Breakpoint. There was a lot of movement towards conservation easements in Iowa, and then the ethanol boom happened about 15 years ago. And because of that, so much more land was put back into production, and now we're putting food into our fuel tanks, right? So that's covered, the details are covered in this book, but that's a whole another fascinating topic. Yeah, great question.
Hi, Peter. So you talked a little bit about the loss you were in, and you were just digging into the agriculture. I wondered, we've got like carbon offsets and other nutrients or chemicals that are being focused on in terms of being able to buy, the ability to put these out into the environment. And I wonder if there's anything like that for nitrogen, that Iowa example. So what's the economics of like using nitrogen or having to pay for the remediation of it?
Yeah, great question. So it is cheaper to put on a few extra pounds per acre of nitrogen fertilizer than it is to miss a yield. All of this, I spoke about a lot of this last night in Hurley during that class, and as someone pointed out in the audience, a lot of that is propped up by subsidies, right? There's a major welfare state for U.S. agriculture. And so I don't think that we'd ever get to a point of nitrogen trading. Just as a point of reference, my advisor at the University of Notre Dame does a lot of this work looking at how to solve the nitrogen problem in agricultural areas. And she did an exercise where they cover cropped an entire watershed, small watershed. Cover crops are, of course, plants that often start growing in October. Then you can sometimes harvest those. Winter rye, for instance, just a way to keep nitrogen on the landscape, keep the landscape green, right? Because bare soil is not a natural ecosystem. And so she studied that in a small watershed, and then she scaled it up to the St. Joseph River, which is the river that flows through South Bend, Indiana. And she said, if we were to put cover crops over the entire agricultural area in the St. Joseph River, which is a pretty good sized river, it would be the equivalent, the nitrate that you would prevent from going into Lake Michigan was comparable to if everyone lowered their pounds of fertilizer per acre from 215 to 211 pounds. 4 pounds of nitrogen. When you're talking about 215 to 211 is not a lot. That got zero traction with the Indiana Farm Bureau. They wanted to still cover crop at a much higher cost, and at you need a lot of buy-in to get cover crop in an entire watershed. So that's kind of the mountain that stream ecologists or people studying water and studying this issue are going up against, that the question of cutting back on fertilizer, which would save money to the farmer, just never gains traction.
I've got another online question kind of along the similar lines there. Are there any efforts to create a Mississippi River protected watershed analogous to the Great Lakes?
We're thinking about it, and we're reaching out to some of the upper Mississippi watershed folks first. So that's kind of an idea that Peter Annan poses at the end of his second book, thinking about a Mississippi River Compact, try to protect the Mississippi River. What's amazing about the Great Lake Compact is it was signed by all governors of all 8 Great Lakes states and the premiers of the 2 Canadian provinces. So it was a real success story in how politics can work. And so when you think about the upper Mississippi River Basin, you've got Minnesota, you've got Wisconsin, you've got Illinois. I could see those governors getting along, but then you have Kim Reynolds in Iowa, who I got to know from living there. I saw her at Costco once. It's a small state, right? It's a small state. Iowa hasn't grown in population either for the last century. It's been 3 million people. So it would require buy-in from all levels of government in those upper Mississippi states, which the Great Lakes did it. So there's hope that the Mississippi could too.
I've got a question. So I know Kansas has a nitrate remediation incentive program for like ag chem facilities. Does Iowa have anything comparable to anything like that? Have they made any efforts in that department?
Absolutely. So what the lawsuit led to was, this is precedent. You can't sue these people for what they're doing. But the Iowa Supreme Court said the legislators should act. This is a legislative issue. So the legislators came up with the Iowa Nutrient Reduction Strategy. Emphasis on the word strategy. It is not, it doesn't have any teeth. It's not regulated. You're not required to follow it. They're just helpful hints. The Iowa Environmental Council, an environmental advocacy group in Iowa, looked at how much action has been taken in the, I think at the time it was the 8 years since the strategy was released. And they estimated that at the rates of adoption of some of these practices, it would take anywhere from 93 years to see any meaningful nitrate reduction to 31,000, yes, 31,000 years for the bioreactor component of that. So when these ideas are suggested without financial incentive, that falls flat. And that kind of relates, when I was living in Denmark, which is about as socialist as you can get, so it's just, I chuckle a little when some people in this country think that we're going to become socialist, because we're not. In Denmark, when I moved there, they had just widened the buffer strips required on all streams between agricultural land and the stream, and they widened it to like 5 meters, really big. And the farmers were upset, but it passed. It just happened, and they adjusted. So it's just like, this can happen, but of course, regulation is a really hard word to think about, to act on.
My question sort of segues onto that. Are there other countries that are doing the same kind of research with the rivers and the nitrogen and those kinds of issues?
Minnesota's doing a lot.
But not other countries.
Denmark is. Denmark, I joked, is the reason I got the job in Iowa, I joke, is that Denmark is the Iowa of Europe. More pigs than people and a lot of agriculture. And so they're being proactive, but they also have a big dead zone problem. A lot of the waters around Denmark and the Baltic Sea, and actually much of the developed world, North America, Europe, Japan, have these dead zones. It's not linked to population because India has very few dead zones off the coast. So industrial agriculture is leading to the same problem across the world, and it's often associated with the more developed countries rather than the developing countries. So again, yet another way that the developed countries are leading a lot of these environmental crises, and the people suffering the most are in the developing countries. But that's way out of my wheelhouse. I better stop there with that.
For Denmark, did you just say that their practice now was 5 meters from a stream?
15 feet, yep. Yeah. They expanded I can't remember the exact number, but they expanded the required buffer substantially.
That's almost nothing.
It's quite well, in Iowa, you can farm right up to the stream. I saw corn falling in, which I questioned. You're losing your land. So yeah, so 5 meters is actually quite a bit. Minnesota's quite proactive in requiring buffer strips. Yep.
Does 5 meters make a difference?
Good question. Does 5 meters make a difference? It does not in places like Minnesota where there's tile drainage. So that's another issue. A lot of the areas of Iowa have tile drainage where there are pipes under the ground that lower the water table. This was part of the lawsuit as well. So they lower the water table so that corn can grow better because corn has very deep roots. And so what happens in those cases is those pipes just go right to the stream and dump out. So one of the conservation practices is you cut that pipe off before the water hits the buffer, so then the water takes weeks to months to get the couple meters to the stream versus the pipe that would do it in seconds. So it does work as long as there's that practice. And just as an example, there was a watershed in Iowa that they completely removed all the tile inlets to a stream and put in these conservation practices of what they call saturated buffers. So the water saturates the buffer. Pardon? Tiers? Oh, no, they just put, so the pipes stop where the buffer is, and then it has a couple meters until the water would reach the stream. But there's an overflow pipe, and the two farmers on this property never put in the control structure that directed the water away from the pipe, so all that water still ran into the stream. So you can do all the conservation you want, but you really have to follow up and make sure that these practices are being implemented the right way. Yeah.
Mike, hey, great talk.
Well,
my family's all from Iowa.
Oh, sorry.
No, it's good.
Then you know what I'm talking about.
He went to college in Iowa at 18, whatever it was. And my undergraduate was from University of Iowa in the early 80s and environmental studies. And the sobering part of it was that all the talk in that environmental field was about nitrates in the groundwater system, and they were blaming it all on the karst topography in the northeast part of the state. So this is, 45 years that they've known it's a problem, or carcinogen, and yet we're still talking about what can we do with it. It's very sobering.
Yeah.
So political action, I suppose.
Yeah.
Do we have more questions?
I grew up in southwest Wisconsin. So
A lot of karst there,
Grant
too.
County is the same as all of Iowa.
Yeah.
Okay. The great dilemma of you suggesting that drain tiles, because to have clay and to have good farm soil, that water had to be underwater sometime. Okay, that's how you make clay. Okay, so prairies were built on top of it. Okay, so this is the best ag country we have in the United States because of the clay. Okay, so we aren't farming the old soils that went down 4 feet, 5 feet from the old prairie that the roots created. So when I was at Platteville in Reclamation Restoration teaching, the farms already had buffer strips. The first watershed probably where Perrier wanted the bottled water. The best water in Wisconsin, besides, I'm sorry, up in where you're teaching now. The best water in Wisconsin was in southwest Adams County. Adams County is all sand except for that one township, New Haven Township. And there was more spring water, but they also produced 220 acres, or 220 bushels of corn per acre. It was a battle. But there was drain tile. But the drain tile wasn't the problem. The drain tile, it was the soil and the water underneath the clay, which created the artesian flow. So when you start talking about geochemistry, what does the prairie do? Okay, this was a solution to Iowa, the CRP, to stop nitrogen all the way from Wausau, Wisconsin, all the way down, is placing prairie and buffer strips. And we've been doing this for 50 years, 75 years now, and we aren't gaining on it either. So the Wisconsin River, the Mississippi River, until we have ethics, laws aren't changing it. Okay, it's back to Leopold and having ethics. I'm sorry, do I have a question in here? No.
I didn't either.
I concur. I did bring some cards if anybody wants to email me afterwards, or I can hang out for a little bit as well. Happy to take another question or two. And yeah.
My question is probably I think it's a really silly one, but one time a friend told me that you should step at least a meter away from any kind of body of water before you urinate. Is that true?
I mean, probably a good idea. It depends what the body of water is. In Iowa, it wouldn't matter. Very little nitrogen. Yeah. Maybe here, yeah. There is a lot of nitrogen in urea. Yeah, yeah, yeah. We just started a Science on Tap in Ashland last month, restarted it after COVID knocked it out. And Susan told me at dinner that this Science on Tap was inspired by the Ashland Science on Tap. So we've got some great speakers. It's the third Tuesday of every month, so you could have twice the fun of Science on Tap. We have a group from Glyphwick talking about Ojibwe climate action plan on February 20th. So come on up to Ashland. It's at a brewery too.
You had mentioned about Arizona trying to get their hands on Mississippi water. By comparison to the Mississippi, how does the Colorado River fare where everybody's sucking as much as they can?
Yeah, the Colorado is in really rough shape. And it doesn't even reach the ocean anymore. You know, it's a real tragedy. Leopold actually wrote about that, speaking of Aldo Leopold, right? He paddled the Colorado River Delta when he was younger, and he couldn't bring himself to go back after that water started getting diverted because he knew it was just so different. And yeah, so the Colorado River no longer reaches the ocean. It's used multiple times before it gets there. The amount of water, Mexico has rarely gotten their allocated amount of water. And when they do get it, it's really high in ions. So it's much more, a lot of chloride. It's just been used so many times and then flowed back into the river. So the Colorado River is really sort of a mess. Yeah.
If there's still time, you'd mentioned about the Waukesha diversion of water.
Yeah.
And I thought there were a lot of communities that took water from Lake Michigan. How is Waukesha different? And can you talk more about that if there's time?
Yeah, I could give a quick overview. And I was only half joking when I said I could come back. I can wait till next year. But so the Great Lakes Compact allows any city within the Great Lakes watershed to extract water, like Milwaukee or Green Bay. Any of those can use Great Lakes water, but it it excludes any withdrawals outside of the watershed boundary. So if you look at the watershed map, it's actually a really small watershed. It's a 12th the size of the Mississippi River watershed. And so the two exemptions are that if you are a community in a county that has the watershed boundary in it. So Waukesha is in the Mississippi River Basin, but Waukesha County has a little bit of its eastern edge that falls within the Great Lakes watershed. Waukesha, speaking of really good water, Waukesha was known in the Chicago World Fair in the turn of the 20th century, 1893. They wanted to pipe Waukesha water down to Chicago because it was so good. The people coming up from Chicago were met with guns. So the Wisconsinites stood up to people from Illinois. Not the only time. So in short, they applied for an exemption to be able to get water from the Great Lakes. All 8 governors had to sign on to agree. So it's really protective in that any withdrawal outside the boundary needs to be agreed upon by all governors from New York to Minnesota. And Waukesha was granted the ability to withdraw water, but part of that is that they then need to return all the water back to the Great Lakes. So they created a pipe then that dumps their treated water into Oak Creek, which is south of Milwaukee, which flows back into the lake. So that's one way that water can be removed from the boundary.
What happened to Waukesha's great water that they had before?
Overuse. It was groundwater. It now has a lot of radium in it because they sucked too deep. So they kept going deeper and then they ran into radium. So it's really poisonous water. So they had to go to the Great Lakes. Yeah, it's a fascinating issue, but luckily it's protected. Yeah.
Time for one more? No? Okay. Well, thanks so much to Peter Levi.
Yeah, thank you.
Thanks, everyone, for coming. Thanks again to our sponsors, Trout Lake Station, Kemp Natural Resources Station, the Lakeland chapter of the Alumni Association, Minocqua Public Library, WXPR, Brittingham Fund, and Rocky Reef. Hope I didn't miss anybody. And remember, our next Science on Tap will be on March 7th with Brian Berenger talking about cannabis. And if you want to sign up for email reminders, we have a clipboard as you're going out the door, and we will put you on an email list, and you'll get a notice next month. So thanks very much. Thanks for coming, everybody. See you next month.